Whether you're writing down an application or a game, if you have to render graphics, you will most likely run into vectors. Today we'll be taking a look at Unity's implementation of a vector. To put it bluntly, a vector is a group of float. In our engine context, it could be used as a vector 2, vector 3, or vector 4. Let's have a look at how we can actually utilize those vector. The most common use of a vector we see in Unity is to define a world position. Whether you're placing object in the scene or modeling something in Blender, there is always going to be a center to the world you're working with. The X, Y, and Z component of a vector is going to define a world position relative to the center. If your center moves, so does all the objects. Same thing applies to the children objects in Unity. The parent pivot's point would be the center of the world for those very objects. So it pretty much goes without saying that Unity uses vector to position objects in the 3D world. Another way you could use them is to plainly store data. Now anything that is made out of 2, 3, or 4 float, you could store it inside of a vector. For example, color data under the RGB format. The X component could be equal to the amount of red, Y would be equal to the amount of green, and then Z for blue. I even remember using a vector 3 to store speed value for my character in a game jam session. I stored his normal speed in the X component, his running speed in the Y, and his crouching speed in the Z. Now this is only for the sake of an example though, I do not recommend doing that. Also, Unity used them as scaling data, so it remembers how it should scale object on all 3 axes at all time. And finally, here's what I consider to be the most useful way to use a vector, using it as a force. This one is a little bit more tricky to understand at first, so let me try to give you a visual representation of it. Start by having your 3D scene and then define a random world position with your vector. Then draw an arrow starting from the center of the world, going all the way to the position you've defined. This is now the force you've defined with this vector. We use that in so many places. When you move your character, you take its position and add a force to move him. That is also how you get your joystick input. If you apply real forces to a rigid body, that is also how you use a vector. Or to define a direction. And pretty much anything that uses a unitary vector, which is basically just a vector that has a length of 1. We'll see more on that in a bit. And those are only few ways you can use a vector. There is plenty more for you to find, but I think we've got enough example to understand what they are. For this second part of the video, we will be looking at some function that can help us manipulate this vector. Okay, so welcome to my scene. Basically, I've got a really simple setup going on here. I have 2 mesh. They're called Carrot Warrior 1 and Carrot Warrior 2, or I mean A and B. And what we're going to be doing is we're just going to be playing around with vector a little bit. We're going to be trying to visualize them and just have a bit of fun with vectors. So on top of that, I have my camera, and my camera has a script called vector. Now I'll show it to you really quickly. And here is what it does. So we have 2 public vector. One is point A, point B. And we also have 2 public transform, Warrior A and Warrior B. Now Warrior A and B, they're pretty much just linked to these transform, these 2. So that would be A and that would be B. Now every single frame, we tell point A is going to be equal to the position of Warrior A. And same thing for B as well. So at all time during this example, just tell yourself that our first vector, our first world position vector, point A, is always going to be on top of this guy, and point B is going to be on top of this one. We also have other thing in here. We also have a force vector, which we will use to just demonstrate the force of things we calculate basically. Now, just below that, we also do a little bit of debug draw line so we can actually visualize. And if I just show it to you really quickly, what we get is we end up with something like this. So it's always drawing the line in between A and B. And it's also drawing a line in between the center of the world and also the force vector. But now we don't really set the force vector, but just say that our force vector would be of 5. Then we'd be drawing a line from the center. The center is actually here. And to the actual force vector. Alright, so let's start and actually have a bit of fun with that. The first thing I will do is we are going to get a vector in between of them. Alright, so let's have a look at this. I've moved my warrior just a little bit so it's not from the center anymore, and as you can tell, there is this line in between of them. We'd like to actually know what this line is. Now, in terms of code right now, what we have is we draw a line between point A and point B, but we don't really have any information on that. And that would be really cool to have information on that, because then we could normalize it, we could get the direction, we could get all the information. So there's a really simple way to do that. All you really gotta be doing is take your point B minus your point A, and this way you can actually create a vector. So let's actually have a look at this. I'm going to be using the force vector to visualize what I just said. So right here I'll say, so if we say something like force is equal to point B minus point A, then our green vector should be able to actually just display, starting from the center, it should display this actual line we saw here earlier. Let's have a look. And as you can tell, it does. So we do now have the information of that line, and we also, well, you know, we have the information of that line, so we can actually get a direction out of this. We can do a normalize. Let's actually go ahead and do that. With this nice information here, let's actually check what is the length of that vector in meters. So to do so, we will go down there, do a debug.log, and we're simply going to print that information by saying force.magnitude. And this pretty much just returns the length of that vector. Again, if we hit play, as you can tell in the console down there, it says 8.5. And if I move this, as you can tell, it's going to get a little bit bigger, and then almost 10. And if we get really close, it's going to be small numbers. So this would be really useful if you're trying to do something like some kind of trigger where the enemies will only be attacking each other if they are like 5 meters apart. So over here it wouldn't work, but then over here it would. And just a tip like that, this is force at magnitude. Magnitude uses the square root, and square root in any computing context is really expensive. So what you could do is just do a square magnitude. This way it doesn't actually have to do the square root, and it saves a lot of juice. So if you guys can work with that, just go ahead and do it. Now there's also another way to get a distance in between two vector, and it is by using the static class and just do vector3.distance. Then you send in point A and point B. This is, however, going to do the magnitude that we just talked about. So again, really expensive. But let's just go back in that debug.log, and I'll just type in something like magnitude, and then do a force.magnitude. This way we can actually always see what's going on down there. What we're going to do, however, is we're going to learn how to normalize that vector. And I'll show you why this is useful in a little bit, but let's do a force.normalize. Now you've got two functions. One returns the vector3, so you could be doing force is equal to force.normalize like that. This is actually a function, I believe, is it? No, it's just a property. Or you could simply do force.normalize, and this is a function that is going to modify force just like this. Now what does normalize do exactly? Let's have a look in the game. This is what normalize do. So even if we're really close, it's always going to be of length 1, as you can tell down there. And you know, the distance doesn't really matter, and this is really useful actually. Now you're probably wondering, why is this useful? Well, it is really useful because say we were shooting a projectile and all we really wanted was the direction. So say just this guy wants to shoot the other warrior. So what you do here is just take that vector, which is a vector of length, let's just assume it's going to be of length 5, and then times your projectile speed, and then let's just say that would be like a that would be 10. So your resulting vector, the actual force you're applying to your projectile, will be 5 times 10, which is 50. but that's not really what you want. You want your projectile to go at speed 10 because that's what is inside of your field. So what you gotta do is normalize first. Now this is 1, and it's always going to be 1 no matter what. So then you can do 1 times 10, which gives you the actual good projectile speed. So this is one of the contexts where it could be useful. Now let's have a look at something else. Let's have a look at something I use quite a lot in the videos, and it is the lerp. Now I'll just create something that I call a public float transition float. It's going to be a transition float. And here's what we are going to do. We are going to say, we're going to create a new object actually. So public, let's use a transform. So public transform, and let's just call it projectile, but it could be really any object that you're trying to position. Or even better than that, let's do the camera. So camera transform. And then every frame, I'll say camera transform is equal to vector3.lerp, and we're gonna lerp in between 2 points. So this is how it is going to work. You're gonna say lerp in between point A and point B, and then you're gonna send in a float. Now this float has to be in between 0 and 1. We'll just send it transition, and we'll modify it directly in the inspector so you can have a look at what this actually does. Right, so I will go under my main camera over here in my script, and I do have an error here. Camera transform dot position, my bad. So we're going to be taking this transform, and every single frame is going to try to position itself in between point A and point B, and now this is how it works. The float that you send, right now it's actually 0, as you can tell here, the transition float, it's 0. It's actually going to determine where exactly on the line you're going to position yourself. So if I just crank this up just a little bit, as you can tell, our camera moves on that very line, and if I decide to just take this guy, it's going to move along with it. So this is really useful. Say you're actually shooting a projectile that is locked on a target, and both target would be moving or only one of them would be moving, then you can always keep the same progression on your bullet at all time. And then when it reaches 1, then you can say, well, your projectile has landed. And as you can tell, once you go past 1, it doesn't do anything else. It doesn't go past this line. Now let's try and turn this into a fighting game. So we're gonna go back here, and we're gonna tell our camera, always position yourself at 0.5. So you're always going to be in between of them. Then once you're in between of them, what I'd like to do is actually just take another vector, another line that is perpendicular to this one, so we can actually go towards this side and always have a look at these two guys fighting. Now this was requested in a comment a long time ago, but it was pretty much just asking for a fighter camera, a fighting game camera, where both of these warriors, they could be moving in 3D space. It's really easy to just make a fighter camera for a single plane, but if they're actually moving in 3D space, but what you're going to be doing if it's in 3D space is actually just take a line that is perpendicular to that, and of course you just position your camera in the center of them. So that's what we're going to do just for fun. Let's actually have a look at how we can actually get that perpendicular line. Now there's something that they should be teaching you in school if you're going to a game design school, and it is the cross and also the dot product. So over here I've got the vector3 documentation, and if we just scroll down to the static function, there is the cross and also the dot product. Now they do have like little images to help you out, and I'll just go ahead and just take a look at them. Basically what you do is you send a vector A vector B, which in return is going to give us something like this, as you can see in the image, and that's exactly what we need for our game. So let's give this a try. Now the vector A is basically something we already have. It is the link in between our two warriors, and vector B would be simply just pointing upward. So if we go in our code, we remove the normalize because we're not going to be needing this anymore. What we can do here is we can say vector3 dot cross, and then you need the vector A, which is going to be force in this case, and then the vector B, which is going to be vector3 dot up. Now you've got multiple of these static vector. I'm just going to show you while we are at it. If you just take a look here, you have a vector3 dot back, down, forward, left, 1, right, up, and 0, and they're pretty much equal to what you see here on this side. So you just imagine yourself that this is for the scene. So when you're saying vector3 dot down, you're going down in the scene view. It's not relative to anything else but the actual world. Alright, let's go back and actually code this camera. So we have the link in between our two warriors, we have the vector up, and this should actually just give us the result we want. Now, since this is a function, I think it does return vector 3, so we're going to need to actually store it somewhere. I'll go up here, say force is equal to this. And let's have a look at what this is going to give us in the game. So it's a little bit weird, but as you can tell, we do get something that is perpendicular to both our thing. And it could actually just work fine. Now if you want this to be pointing the other way, because right now it's pointing towards, well, if we just apply this to the camera would be on this side looking at these guys this way. If you want it to be the other way around, what you could do is instead of sending the vector 3 dot up, you can be sending vector 3 dot down. So it would reverse the actual drawing we saw. This little drawing here, and then B would be pointing down, so the result would be pointing towards this side. Let's have a look at this. And here we go. Okay, so now if we do want this to work, what we have to do at this point is just get our middle point like we used to do. Then we put our camera there and we do plus this force vector. So let's give it a try. Camera position is equal to the lerp in between both of them, and then let's do plus force, which should end up giving us a result that actually works. Let's have a look at this. So here is our camera. If we just move it, okay, right now, so right now my transition is at 0. So let me put that in the middle point. And as you can tell, we're now in the center of this line, and we're pretty much just perpendicular. So if we just decide to go in 3D space and rotate around, as you can tell, the camera is also going to rotate around. And that is how we could create a 3D fighter game. And I'll just put that here so we can actually have a look at this while the game is playing. Now, the only problem if we're actually just trying to create something of the sort is the fact that the camera is not really looking at us, and that could be fairly annoying. So here's what we're going to be doing. We are going to say camera transform look at, so camera transform look at, and it is going to look at this point, which is, you know, the middle point in between both of these guys. So this way the rotation of the camera should always be looking in between them, so something like that. And as you can tell, they can now fight, and we have a very good time. Now, of course, the camera, not camera, but the players would be rotating as well while we're playing. And finally, let's actually address one more problem before we call it a day. If you have a look at this, it's right when it's about here, that's just fine. But then if we go a little bit too far, then that's not really cool. So what we'd like to do is actually tell this guy to clamp itself at one point. Now we know that this is always going to be assuming the force vector, the one you see over here. But what you could do instead is you could be normalizing that vector and then just applying a fixed distance. So let's go step by step, try to do what I just said. So we're going to go inside of our code, and right before applying the new position, we're going to do a force.normalize. Now this way we're going to end up with something like this. As you can tell, the camera is very, very close to them at all time, and it is because the camera is actually 1 meter away from the middle point. And now, by the way, the reason we do see them this way is because I am in orthographic view, so I'll just remove that so we can actually have a better look at what's going on. As you can tell, this is definitely not going to work, so we need some kind of fixed distance in the back. But right now, we've normalized our vector, so the middle point is right here, and then we do a plus force, so plus this vector, which is of length 1. Now to apply a fixed distance to this is going to be really, really simple. We'll do a force times equal and then a float. So we could be saying 10. This way it's going to be 10 meters from the actual middle point. And there we go. We end up with something that is more enjoyable to look at. And as you can tell, it rotates again and it has this fixed distance. Even if they're really close, still has the fixed distance, and even if we go really far away, it's still at 10 meters. Now, of course, if you'd like to actually go a little bit further than that, you're gonna have to actually not clamp your value, but, well, maybe you could clamp in between a minimum and maximum. It's really up to you guys. But yeah, I'm going to be calling it a day. We played with vectors quite a little bit, and they're quite fun, to be honest. And it's pretty much something you need to understand before you get started making a game, basically. I hope you guys enjoyed this. I hope you learned something, and if you did, please leave me a like. Really appreciate that. As always, your support is just amazing on these videos, and I'm gonna keep doing them as long as I can. Other than that, please check out the Patreon page if you wish to support me. Question, comments, you can do that in the comment section below or in the Facebook page. That is actually just a little bit faster. If you go through the Facebook page, all the links I've been talking about are in the description below. And other than that, guys, thanks a lot for watching, and I will see you next time.